This is an A-level pure question on integration by substitution. Okay, we need to show that the integral between the limits of 0 and 2 of 2x times by root x plus 2, all integrated with respect to x, is equal to 32 over 15 bracket 2 plus root 2. Now in a question like this, we need to decide what method we're going to use. Okay, so let's start with patterns. Do we have this type of pattern here where I can see one function to a power and it's multiplied by the differentiation of that power or of that function? The answer is no. So let's cross that out. Do we have the same type of thing but a division pattern where I see a function and that function differentiated at the top of the fraction? No, so it's not going to be that. Is it trig identities? No, there's no trigonometry at all. Is it integration by parts? It possibly could be. I can make this 2x part here u, and then this part here dv dx. But really we want to use integration by parts when we have a product, where we've got a product here, but the two parts of those products are things that are completely different in maths. Like for example, one is an exponential and one is a polynomial, something like that. We've got a polynomial times a polynomial, so integration by parts is probably more work than is really necessary. However, substitution would be a good way forward in this question, because I could use substitution, and I can see I can probably substitute all of these different parts of the question in terms of u. So when you have this type of question, you really want to be looking at what's the thing that would be inside brackets if you wrote it with brackets. And the bit that would be inside the bracket is x plus 2. If I write this to the power half, and it's this bit inside the bracket here that's a good starting point for substitution. Look for that, x plus 2 in this particular question, and then what I want to do is to use the substitution x plus 2. So I'll write u is equal to x plus 2. So what I'll do, I'll color code all of this so I can see what bits I want to substitute. Whatever substitution you make, you need to differentiate that. So I'll have du dx. Now that will just equal 1. I can rearrange that to get du is equal to dx. So that will be another substitution. So that means that I can take this dx out here and replace it with du. Okay, so the last bit that needs substituting before we get to the limits is this 2x. Now I can take this u is equal to x plus 2, and I can use that to make 2x. So if I start with u is equal to x plus 2, and then I take 2 away from both sides, so I'll have u minus 2 is equal to x. Then I will have 2x is equal to 2u minus 4. So there's my final part of the substitution. So 2x is going to become 2u minus 4. And now we also need to substitute the limits. Don't forget about that. And I'm going to do a little table here to substitute my limits. So my x limits are 0 and 2. I want to turn those into u limits. So I can just use my substitution. So I take the x limit, add 2 to get the u limit. So when the x limit is 0, the u limit is 2. And when the x limit is 2, the u limit is 4. So now I can do all of the substitutions. So let's do the limits. So 4 at the top, 2 at the bottom. 2x, that's going to become 2u minus 4. That was the thing highlighted in blue. The x plus 2 is going to become u, so u to the power half, square root of u, and the dx will become du. Now let's expand the brackets, keeping the limits the same. So if I expand the brackets, I will get 2u to the power 3 over 2 minus 4u to the power half du. Now I can do my integration. So remember, you add 1 to the power, divide by the new power. So I will have 2u to the power 5 over 2 divided by 5 over 2, and then minus 4u to the power 3 over 2 divided by 3 over 2, and the limits of 2 and 4. Let's tidy up what we've got in the brackets. It will be easier to work out when I get these fractions and numbers worked out. So I've got the first bit here. So 2, if I divide that by 5 over 2, that becomes 4/5. So I will have 4/5 u to the 5 over 2, and then minus, and then 4 divided by 3 over 2 gives us 8 over 3. So minus 8 over 3 u to the power 3 over 2. So now the limits can go in. So let's start with 4. So I will have 4/5 times by 4 to the power 5 over 2 minus 8 over 3 times by 4 to the power 3 over 2, and then subtract from that 4/5 times by 2 to the power 5 over 2 minus 8 over 3 times by 2 to the power 3 over 2. So let's evaluate bracket by bracket. So the first set of brackets, if I work that out on my calculator, that gives me 64 over 15. And then I need to subtract what I get from the second set of brackets here. Now the problem is, if you just type this second set of brackets here on your calculator, you get a decimal answer. It's like something like minus 3.01 and so on. This is given with a root 2. So we're going to have to evaluate this second bracket manually. Okay, so let's sort this bracket out. That's a bit better. Right, so here I've got 2 to the power 5 over 2. So the 2 at the bottom is going to give me root 2. Then you've got root 2 to the power 5. So that's root 2 times itself 5 times. Every time you do root 2 times by root 2, you're going to get 2. So I'll basically get 2 times root 2, or 4 root 2. So I'm going to get 4/5 times by 4 root 2. That is the exact value of 2 to the power 5 over 2. Our calculator can't cope, unfortunately, with that. And then 8 over 3 times by, again over here, 2 at the bottom is going to give me root 2. Then root 2 cubed, root 2 times root 2 times root 2 is going to be 2 root 2. So 2 root 2. Okay, so now my calculator can cope. So I've got 64 over 15 minus, now the calculator gives me a negative 32 root 2 over 15. And even if, like, we wanted to, this could be worked out all manually without having to go for a calculator. And in fact, you can probably work it out quicker manually than you could type it on a calculator. Right, so yeah, it's minusing a negative. Sorry, I forgot about the negative there. So we've got 64 over 15 plus 32 root 2 over 15. Now, whenever we get these types of questions where it's a show that, we must always give our answer in the exact form that they've asked for. So, just one more step, we want to get it looking exactly like what we've been asked to do. So there needs to be a 32 over 15 outside the brackets. Now to get 64 over 15, the first term in the bracket needs to be 2. And this 32 root 2 over 15 needs to be multiplied by root 2 to get that second term. So now I can see it's exactly what they require.